I'm going to talk to you about both groundwater quality and groundwater quantity and hydrology. It's called the Golden Triangle by some people. So what I'm going to try and do is give you a picture of what's going well in the zone from a groundwater and kind of hydrology perspective, but also the challenges that we're facing and some of the things that we need to work on as we move through this Land and Water Solutions program. So in terms of groundwater use, I thought I'd better just start off by saying, why groundwater is important, and probably I'm preaching to the choir here a little bit, because a lot of you will have private water supplies for your drinking water. So over 8,000 people in the zone we've estimated are on private water supplies, and another 45,000 people served by community supplies. And most of those need very little, if any, treatment at the moment to deliver potable water. So it's a really important resource from a drinking water perspective, but it's also really important from these other uses. So this is wells registered on our database, and you can see that there's over 1,000 irrigation wells and 2,000 domestic supply and stock water and so on. So groundwater is really important from a water supply perspective, but also it's really important in terms of sustaining flows in our spring-fed streams and our rivers. So we've estimated that there's about 7,000 litres a second on average of groundwater going out to these spring-fed streams. And this little schematic here is just emphasising that relationship between groundwater levels and flows in these streams. They're very sensitive to groundwater levels, so you get a small drop in groundwater levels, you can see a very large reduction in spring-fed stream flows. So I'll come back to that point a little bit later in the presentation. So moving on to groundwater quality now, just a really quick snapshot of where we're at. I'm going to focus on nitrate. The current state groundwater quality report has got more detail on some other parameters like contaminant microbiology and some of the natural parameters that can be high in the zone. But anyway, as far as nitrate goes, we're sitting at a median concentration of about 3 milligrams a litre. Now the drinking water limit for nitrate is 11.3, so we're well below that as a median concentration. And just looking at how we compare to, firstly, New Zealand. So there we are at about 3, New Zealand somewhere between 1.5 and 2, and Canterbury at a whole about 3.6, 3.7. So somewhere in the middle there, not doing too badly, but a bit worse than New Zealand as a whole. So how do we do as far as the drinking water standards go in our wells? Well, pretty well, actually, compared to some other parts of Canterbury. Only about 3% of the wells we've sampled have exceeded the drinking water standard of 11.3 milligrams a litre. And we've sampled a lot of wells over the years, so that's actually pretty good. And so there's been a few hits around here at Cust. I understand that was a former piggery kind of point source discharge that has since gone away. And so a reasonably good picture of drinking water quality with respect to nitrate. Microbiology also looks reasonably good as a whole. So where are we going from here? So this is where we look at trends in, you might just want to flick on through. This is where we look at trends in nitrate over time. Some kind of graph Adrian showed where we've got our nitrate concentration on the axis there, data going back to about 2000. We've been monitoring quite a few wells for quite a long time. And so here, look, you can see we've got a well at Airwell, Clarkville, Swannanoa. And some of these wells are kind of tracking along steady, but in others we're seeing nitrate concentrations like that slide Adrian showed for Silver Stream, I think it was, probably this one here. We've seen concentrations bump up a little bit in recent years. So in some areas we're heading in the wrong direction with respect to nitrate, and that's not a big surprise when we kind of come and turn the zone from being relatively low intensity agriculture to much higher intensity irrigated land. So, right, on to groundwater quantity. So a very quick orientation of the zone. These are our groundwater allocation zones. Some people might be familiar with them, but if you're not, this is the Aire River zone. Here, where we are now, is our Cust allocation zone. We've got Lowburn Fan, the Ashley zone, and the Kowai zone there. So we'll just move on and talk about groundwater allocation over time in these zones. The thing to pick out here, here's the annual volume of water allocated in each of these zones. So the big story here is the Aire River groundwater allocation zone. In the late 2000s, we were sitting about 50 million cubic meters a year of water was allocated. Then boom, over the last few years, we've jumped right up. We've doubled from 50 to about 100 million cubic meters a year. Whereas when you look at the Cust, stayed pretty steady, and the Ashley, slight increase, but completely dwarfed by what's been going on in the Aire groundwater allocation zone. So that's where all the action's been over the last few years. So this colour scheme here shows where we are in relation to our allocation limits. So the air zone is now 100% allocated. We would be declining any consent applications to take new groundwater from this zone. Whereas the other zones, Cust still got some more water available, about 30% allocated. And I think like the Ashley zone, somewhere around about 50% allocated. So more consents could potentially be granted if we carry on our current direction in those zones. Right, so what's been going on and where are we going as far as groundwater resources goes? Well, this graph here is looking at rainfall recharge to the aquifer. This is purely the climate kind of metric of how much water is recharging to our aquifers. And you can see we've had wet periods and dry periods, but the overall trend is downwards. So when we do some trend analysis for that, we find that there's been about a 15% decline in rainfall recharge to our aquifers in this zone since about 1999. So what does that mean? Well, when we look at all our groundwater levels, you can see here, if you add up these numbers, that we're monitoring about 40 wells, or have been monitoring for a long enough period to do some analysis. And when we do the trend analysis on those data, about 20 of those wells have shown no real trend. They're kind of flatlining. About 9 of them have declined, and about 8 have increased. And the average change, if we average that out over the whole zone, is a 0.2 metre increase, so fairly steady. So this looks a bit odd at first glance. We've seen this huge increase in groundwater allocation, but we're not seeing groundwater levels dropping off. So why is that? We've dug into the data a little bit to try and understand that. And we've realised that there's a bunch of mitigating factors that are explaining that story. First of all, the Will Irrigation and Stockwater race scheme is, fortunately, from a water resource perspective, pretty leaky, and we estimate that it loses about 1.2 cubic metres a second of water on average over an average year. And then we compare that with the amount of water that's actually abstracted from the zone rather than just the allocation from the air and Cust, and that comes out about 1.7 cubic metres. So this is almost entirely offsetting that. We're about half a cubic, 500 litres a second in the red still after this. But then the other factor we need to look at is what happens when we irrigate land. We're obviously increasing the moisture content of the soil to allow plants to grow faster. When we do that, it means that more of the rainfall that falls on that land with kind of more moist soil can get through to the groundwater. So we have this increase in kind of groundwater recharge, which we call irrigation-induced recharge. That equates to about an 18% increase. So we had that 15% decline due to climate, but we've got 18% increase due to irrigation. So you can see that there's no real net change in the water budget. It's fairly well balanced, and that tells us why we've had this huge increase in abstraction, but our water levels that we're seeing in our wells are staying around about the same. Okay. Right, a couple of quick slides on hydrology, and I've focused on the Ashley River, Waimakariri, because it's really where the action has been as far as the kind of climate drivers go. So here's the same kind of exercise that we've gone through in terms of trends analysis for the Ashley River. Now, the really key thing here is this site here is at the gorge. This is upstream of any major groundwater or kind of groundwater connected abstractions and surface water abstractions. So this is really telling us what's going on climate-wise to flows. And again, we've seen about the 15% decline in flows over this period. So that equates to about a 1.3 cubic metre a second reduction in flows since 1999. So what does that mean? Now, the Ashley River is the major source of recharge to this groundwater allocation zone. We've been doing some work on this, and we think it loses about 5 cubic metres a second of water to this zone here on average, which is a fair chunk of flow. So when we see that flow there declining, then we can expect that flows in some of these spring-fed streams are going to drop off, and we can also expect groundwater levels to drop off. So what do groundwater levels look like in this zone? Well, they look a bit like this, actually. No surprise that with that decline in the Ashley River Waimakariri flows, we've seen groundwater levels in about 4 of our 5 monitoring wells in this area declining reasonably steady. Here's the earthquake that came along and made a bit of a shift in groundwater levels, but this is generally the trend of declining levels. So kind of doing some fairly simple analysis, I've estimated that about 70% of that decline is due to the Waimakariri flow, kind of declining over time, and about 30% of it is due to kind of this reduced rainfall recharge and groundwater abstraction together. So looking kind of more broadly, in the Silver Stream catchment, we've also seen a slight decline there, which is probably due to a combination of groundwater abstraction and irrigation conversion. There was a border dike scheme upstream there. That would have been losing a lot of water to ground, so with that turning to more efficient spray irrigation, we probably saw a bit of a decline associated with that. So those are probably the two drivers for what's going on there in Silverstream, and as I say, we're probably seeing a decline. We have to use groundwater as a proxy for spring-fed stream flows because we don't often have long continuous records, but we know that they provide a good indication of kind of what's going on to flows. So yeah, just to kind of sum things up then, drinking water quality in the zone's generally pretty good, but nitrate is trending upwards in the Kaiapoi River catchment. The Will Scheme recharge and the stockwater race system has offset the effects of a large increase in groundwater abstraction, but we're seeing some groundwater level declines in the Ashley groundwater allocation zone and the Silverstream catchment, and so there's some implications there for stream flows and well reliability. Right, so this is my last slide now. What I'm going to try and do here is talk about outcomes from a groundwater perspective. And the Olympics might be well and truly over, but I'm going to be giving out medals still tonight. But it's kind of a bit like a kids' school sports day where PC's gone mad. Everybody gets a medal tonight. And it's kind of the Canterbury Olympics, not the World Olympics or not even the New Zealand Olympics. It's kind of a relative medal system, but I just want to try and make it easy to follow. So first, one of these outcomes that we've heard talked of in a couple of previous presentations, safe and reliable drinking water. I'm giving that one a silver medal because water quality is pretty good. But we're seeing a few declines in groundwater levels, particularly in that Ashley zone. So that could be signaling a reduction in well reliability. So we're not getting the gold there, but we're above bronze. We're doing okay as far as drinking water goes. The next one is irrigation water. And again, I've dished out a silver medal for that one because I think we're not, over the zone as a whole, we're not seeing big declines in groundwater level. When we do some analysis, I reckon in a drought year, about 80% of wells are probably reliable, but I'll be interested in getting some feedback on that later in the evening, perhaps. So moving on to kind of recreational habitat and customary use of the major rivers, I'm giving that a bronze, not because groundwater is causing a major issue, but because particularly the Rakahuri, as we've heard, is under some stress, and groundwater abstraction is probably not helping a system that's already feeling the pinch from a drier climate. So moving on to the diverse aquatic life in the Hingakai and our spring-fed streams. Again, that one's going to get the bronze because we're seeing these increasing nitrate concentrations. But as Adrian's saying, these streams are already under pressure from other kind of aspects of land use, and so increasing nitrate concentrations aren't helping, and those declining flows also could exacerbate what's going on. So this, I guess, in summary, there's the challenges for us are on kind of these areas. We just need to make sure that what's going well here in terms of these particular aspects, we keep on doing that and try and improve things through our solutions program as we get into that stage.